What's up, everybody? This is Ryan here, and you're watching episode number 4 of my new live stream Q&A. I've got some very spooky Halloween lighting going on, but hopefully it's better than the lighting that I had before. So, welcome to today's show. So what I'll do is I'm just going to wait a few minutes and just kind of ramble at first, just for a couple people to join. And then what we'll do shortly thereafter is we'll get into the primary content for today's episode. For today's episode, I hopefully have what'll hopefully be an entertaining story to tell you. It's a true story about me failing epically on a coding challenge that I went through about a year and a half ago, which was part of the selection process to get hired as an Android developer. So I'll be talking about that. And then that's actually kind of going to be a lead into the primary lesson content for today's show. And the primary lesson content for today's show is talking about the benefits and drawbacks of using too many libraries or using many libraries or frameworks in particular, which is something we're going to talk about. And a couple different topics, like I'll just give you a quick summary. So I'll tell a story about why this is really important for people looking to get hired. We'll talk about what the words third party, framework, and library actually mean. Now, in fairness, there isn't actually a consensus, particularly on what framework or library means, but I'll give you some ideas, some ways of thinking about it. And then there's also, we'll talk about the general benefits of using libraries and frameworks. We'll talk about the problems from using libraries and frameworks. And then we'll end by talking a little bit about how to mitigate, reduce the problems that you can get from using frameworks. So that's basically what my plan is for today. But yeah, I'll just keep rambling for a moment longer until we get a few more people, and then we'll get started. But yeah, how is everyone else's Sunday going? I had a pretty good, productive morning. I was up at 5 a.m., did my usual routine, breathing, a bit of meditation. I live streamed a workout this morning on Facebook, not here. And like I was saying there, the whole purpose of doing that is kind of encouraging people that even if you're a nerd like me, like I'm a computer nerd, don't get me wrong. I have other aspects to my personality, but I am a nerd. And that's actually not an excuse for not working out or not taking care of your health or anything like that. So I'm trying to demonstrate to people, like, even if you just work out 20 minutes a day, for me it really helps my brain work better so that I can talk and be in a good mood and spend many hours writing code. So what have we got here? Ashish, what's up? And we have a cousin from home country. Cześć, Peter. Jak się masz? I'm actually a little bit Polish. Peter says greetings from Poland. But yeah, I am part Polish. That's actually where the smart part of my genes comes from. So yeah. Anyways, well, I won't hold things up for too much longer, and we can get started with the story time and then the actual lesson. I think I'll try and make this story pretty entertaining for everyone watching, because it's a story about me failing, and I'm not afraid to stand here and talk about failing hard. There are two kinds of people that fail and liars. So, all right, I think we'll get started. Let's get down to it. I think we've got enough people, so we can go ahead and get started. What's up? Not sure, Tejas or Tejas? Oh, by the way, before I proceed, I just want to give a big shout out to Rowena Polak for donating to me via PayPal. Much appreciated. I know many of my viewers don't have money to donate. Many of you come from poor countries. I actually come from a lower middle class family, even though I'm Canadian. So I totally get that. But I do appreciate donations, and if you're someone who likes to help out but you don't have the money, if you want to help, just hit the like button, share this stuff with your friends, and stuff like that. Check out my Skillshare links down below, and that's my commercial for today. Okay, so let's get started with story time. So what I'm going to do here, I'm just going to talk at you for a few minutes, and I'll tell the story. And then what we'll do is we'll get into some specific examples. I have some examples pulled together. We'll go through some definitions. We'll do hopefully a 20-minute lesson, but you know me, I like to talk a lot. That's why I'm here. And then we'll get into the regular Q&A. So let's get started. So let's talk about something that happened a little while ago, about a year and a half ago. So at that time, I was looking for a contract role as an Android developer. So basically what happened is that I applied to a local mid-sized startup, and I went through the basically the interview. Let me just make sure I don't get all lost in my notes here. So basically what I did is that I found a job posting for a contract developer role. I was really confident walking into the interview process because I had spent hundreds of hours using tools like RxJava, Dagger 2, Android Jetpack, Room, Realm, Retrofit, Firebase. Also, the job application mentioned Kotlin. And at that point, I had basically only written code in Kotlin for about a year. So I was very good with Kotlin, very comfortable with it. They gave like a small list of some APIs they like to see. So I was pretty confident coming into this particular job interview process. So the first thing I did is I had an interview with their recruiter/HR person. And I usually do really well in those kinds of interviews with non-technical people because I used to work in sales. So I know how to, I don't want to swear because I might get demonetized, but I know how to BS people. That was my job for years. So I got through the first interview, non-technical interview with the HR person. And immediately after, they sent me a coding challenge, which I failed hard. And this story is about how I failed, why I failed, and what I learned from that. So let me just zoom in on my text here, and we'll get started. Okay, so let me just first describe the coding challenge that I was given. So the most important thing here was the rules of the coding challenge. So you have to keep in mind, I have a lot of years of experience with Java, but I had been writing Kotlin for like a year, so I was out of practice with Java. So the very first rule of this coding challenge they gave me is that I had to write in Java. Not a big deal, but when you're used to Kotlin, going back to Java, it's like going from I don't know what a good analogy here is, a motorbike to a tricycle. It's uncomfortable and you just don't go as quickly. So that was the first rule of this challenge. Not that big of a deal, but inconvenient. The second rule of this challenge really threw me for a loop. I was not allowed to use any third-party libraries whatsoever. Pure Java, pure Android SDK. The third rule is that I only had 2 hours to complete this challenge. Not a big fan of that format, but that's the way it was. So the challenge itself was pretty simple. I had to build a very basic UI. I had to download some data from a REST server, so a cloud server type thing to use the buzzwords. And then if I had time, I had to write a speed test for that download. So here's the thing. At this time, because I had spent so much time working with libraries and frameworks, and that was really mostly what I knew as an Android developer, I had no idea what an HTTP URL connection was. I had no idea what a socket was. I had maybe some ideas, but I didn't know how to implement it. And the last time I had implemented a background service, which is one of the ways you might want to download data on a background thread, was like 3 years before that. Combine that with the fact that I'm like pretty out of practice with Java. I was really used to using RxJava for concurrency too. And to be perfectly honest with you, I panicked. I made a really stupid judgment error. So at the time, I did not actually have a strict definition of what third-party library meant. I thought RxJava, obviously that's got to be a third-party library. So I knew not to use RxJava because that was one of the rules of this coding challenge, no third-party libraries. But because I didn't have a good definition of what third-party library meant, and because I kind of panicked, I wasn't really thinking straight, I decided to use Volley because I thought, okay, well, it's built by the Android team, so it's not third-party, right? Wrong. So just to give you a glimpse ahead, in reality, a better definition of third-party refers to any library or framework which is not part of the platform SDK. So we're here in this case talking about the Android SDK, and not part of your library, your language's standard library, so the Java standard library. So that's really defines what not third party is: Android platform SDK and the Java standard library. And I screwed that up. So let's make a bad situation even worse. So not only did I instantly fail one of the rules because I screwed that up and decided to use Volley, guess what? I had never used Volley. I used retrofit and OK HTTP. So not only did I decide to use a third-party library, I had 30 minutes to figure out on the fly for the very first time how to download some data using Volley from a REST application and to serialize that from, or deserialize from JSON. So yeah, to wrap this story up, and we'll get into the technical content now, I failed horribly on that coding challenge. Even though I'd been studying Android since 2014, and this coding challenge was only about a year and a half ago, I completely bombed it. But like everything else in life, every failure presents an opportunity to learn, and I will fix my mistakes or die trying, which is why I'm still here talking to you. So let's talk about what I learned from that experience and how I tried to fix those mistakes. And just a reminder, you know, everybody completely fails from time to time. So don't let that become like some giant overarching part of your character. It was just a perfect storm of bad things happening and a specific set of rules which just really didn't work with what I was used to. So now let's get into the lesson and we'll talk about how to learn from this situation. And I'll give a general explanation of how you need to be careful with your third-party libraries and your frameworks. Let me just open up a WordPad document. I'll pull my notes over to the side. And just give me a few minutes here, everybody. I won't be able to see the chat for a minute because I have many windows open, but we'll try and get through this pretty quickly. For those who actually want to really learn here, you might want to take some notes. I will basically share what I'm saying in the form of notes on the screen here for you. And we'll also look at a few examples from some libraries and some pictures and stuff, basically teaching tools. So let's start by defining the words third party, framework, and library. I'll just zoom in here a little bit. We'll do font 20. Okay, so let's start with third party. I basically defined this already, but let's just go over this one more time. Anything which is not part of your platform's SDK, like I said before, in that particular case, the Android SDK, or your language's standard library. If you've ever seen JSTD_lib, or however they choose to write it, this stands for Java Standard Library, and I totally misspelled it. JST, well, I guess I didn't. Yeah, JSTD_lib stands for Java Standard Library. So let's look at a couple examples just so that you know exactly what I'm talking about. If I pull up an Android application, let's see, which one should I use? So all of this stuff, you see this comes from the Android SDK. So this is perfectly acceptable. These things are not third-party libraries. So that's kind of a clear example there. And then we have obviously the tools of the language. Like we're using Lambda expressions because this is Java 8+. So those things are definitely not third-party. Now we'll talk about third-party libraries and frameworks. Now, before I proceed, I need to tell you something important. Not everyone agrees about, agrees about these definitions. So what I'm going to try to do for you here is I'll give you a way of thinking about it, but don't assume that my definitions are correct. I will define them for the purposes of this lesson, and hopefully you will use those working definitions, but just understand some people might say that's not what I think a framework is or a library, and I don't really care. There's no real consensus here. Okay, so let's start with an example of a library. So a library, let's see here, is some collection of source code which you can plug into your source code, so we're talking about your projects, to solve a problem. So this is a very generalized definition. It's something that somebody else wrote, or maybe you wrote in a different program, and the idea is that you can just plug it in and play. Now, it's important to understand the stuff that comes from, for example, the Android SDK. These are still libraries, so we need to understand that a key distinction here is the third party. Now, that hopefully is fairly unambiguous, and if we want to think of some kind of example, well, here I have the recycler view library. It's not part of the plain Android SDK. So it is technically third party using my working definitions, even though it's made by the Android team. And it exists to solve a particular problem. And so in this particular case, the problem we're solving is that we have large list views and we want to implement the view holder pattern. And so we'll talk about this example again later, but this is kind of an example. This is an example of a library. Now we need to contrast that with a framework. So a framework, as the name implies, is a kind of library. So here's an important point. A framework is a library, but a library isn't, not all libraries are frameworks if you follow my definitions here. So a framework, as the name implies, is a kind of library which is a fundamental part of your application's function and architecture in particular. So in order to kind of demonstrate what I'm talking about here, let's kind of look at an example. So we can kind of think of as a library like the recycler view. In this case, it's just some particular problem in the structure of a program, whereas a framework, we're thinking about something more like this. You build around it. So again, just to reiterate, understand that a framework is technically a library, in my opinion. It's included in that type, that class. It's a subclass of library if we want to use some programming jargon. but not all libraries are frameworks. Now let's look at a code example to demonstrate this point. So here I have a really old application. This is from like 2016 or something, maybe, no, 2017. And all I want to show you here about why I'm saying this thing is like a major architectural part of your application is in this application here, I used to use RxJava all the time. Now, if I look at a front-end class, so here we have, or sorry, that's the wrong one. If I look at a front-end class like a presenter, and don't use this code as an example, I was a much crappier developer back then. But here we have already we have our RxJava stuff. You can see it's implemented here through the libraries. And we're using Flowable, and we're using all kinds of RxJava stuff. And then if I jump into the very other end of the application, again, we see the usage of RxJava. So the important distinction here is we basically see often an end-to-end structure which you use to build your application. So hopefully that makes sense for people, and that's kind of how I think of a framework versus a library. But again, not everybody agrees. So let's move into the second point here. And this point is about the general benefits. General benefits of using libraries. Now, understand I am generalizing here. Not every library is going to give you this benefit, and we're going to talk about the problems frameworks can give you, and not every framework is going to, library is going to give you problems. I apologize, I will probably be using the word framework and library interchangeably. That's just how my brain works. Sometimes I use the wrong word. Deal with it. So let's get started here. So number one, first benefit of using libraries, and this should be pretty familiar. So a good library hides the implementation details, the code necessary to solve a problem. And in technical, let me zoom out a little bit. That's probably big enough. In technical terms, a library adds a layer of abstraction over the solution to a problem. So what is an example? We'll use the example that I just showed you earlier. So the purpose of a recycler view is basically, let me see if I can even find that's a lot of documentation. The purpose of a recycler view is so that I do not need to implement the view holder pattern myself. Does that mean I can't implement the view holder pattern myself? No, I could learn how to do that. I'm sure anyone watching this could. But in this particular case, I'm not interested in solving that problem. The recycler view in particular, I find is a very good library. It doesn't take over my whole architecture, and it solves a problem that is pretty common in my applications. So this is an example, in my opinion, and everyone has different opinions, of a good library. Okay, so that's one of the points. A good library hides implementation details necessary to solve a problem. In other words, a good library, to put it in really simple terms, can be plugged in and used even sometimes by junior developers. Sometimes some of these problems are really complicated, and if you're a junior developer, you just want a solution that you can figure out relatively quickly and then get some meaningful programs working. I'm sure if any of you have any experience in web development, you'll be familiar with libraries which allow you to basically build the framework or the basics of a website in like 5 minutes by typing a couple imports. All right. So I just lost my spot in my notes. Just give me a minute here. And here's another point. So a good library, depending on what your goals are, can solve many problems at the same time. And here we're getting back into framework land, because this is what frameworks like RxJava do. So in the case of RxJava, it is simultaneously an implementation, a version of the observer pattern, the publisher-subscriber thing, a threading, let's just say, I apologize if my English is a bit off here. It is simultaneous an implementation of the observer pattern, a threading mechanism. You can do concurrency with RxJava, and it allows a functional, depending on how you define that, style of method chains, and functional functions like map and all those kinds of things that we tend to see in functional languages. So this is what I'm talking about. It can solve many problems at the same time, but here's the thing about that, and this is where we'll get into the next main point here. Sometimes that's a bad thing. So here's point number 2 about this. So what are the problems that can arise from using frameworks? So hopefully you watched my story or listened to my story from earlier where I explained this exact situation and how I completely failed a coding challenge because I basically used too many frameworks and didn't know how to solve problems without them, to generalize a bit. And understand the examples I'm going to give you here, it's going to depend on the library and the framework. I'm generalizing. So one important thing to remember is that very often the details that these tools hide from you are worth learning to become a good developer. So sometimes this isn't the case. I'm not overly interested in manually implementing the view holder pattern itself, but recently I did basically make my own simplified version of RxJava. I made an implementation of the publisher-subscriber pattern or observer pattern. And that was worth doing. I learned a lot from doing that. Here's a more important technical point when it comes to software development life cycle. So frameworks or libraries tend to change frequently, and if you've spent more than like 2 years in any platform, you've noticed that almost every 6 to 12 months there's a new framework that does what the old frameworks do, and everyone gets excited about it and they think it's the best thing, and then 6 months later or a year later another new framework comes out. So frameworks and libraries tend to change frequently, whereas platforms and languages tend to change much less frequently. So if I solve a problem with a library or framework, I will tend to have more upkeep. I will have to keep updating version numbers. I might have more frequent application breaking changes, although in fairness that can come from platform updates too. I've had that happen too. But the point is, it's less upkeep if you implement the solution yourself oftentimes, as opposed to using the framework or library. And here's another point. So just to summarize this, your code becomes more resistant to change is the goal there. And let's talk about the elephant in the room. And this might anger a few people, but I'm just going to speak the truth as I see it. Sometimes, and Dagger is a perfect example, and I know they have Hilt out now, whatever. Sometimes, using a library is, oops, did I spell that? Yes, I did spell that right, is a gigantic waste of time. Now, that's going to piss some people off. Let me explain what I mean, because I do mean something specifically. Okay, if you are building a small app to learn Dagger 2, that is good. I encourage that. Build a simple application to learn a complicated tool so that you only have to worry about learning the tool and not worrying about building a complicated application. I strongly encourage that. Okay, if you are building a small app, otherwise, let's add that in there. Otherwise, if you're building a small app that uses Dagger 2, then you are basically, let me scroll down so my face isn't blocking anything, then you're basically doing something like driving a tank to go pick up groceries. It is just complete overkill. You will give yourself extra work for no benefit. The code that Dagger 2 would generate for you in a small application is simpler to write by hand. It's very simple. Let me show you what it looks like right off the bat. You write a little class called, what do I usually call it? Build logic. And this is, in a nutshell, what Dagger 2 does for you. You give it a view or some context or something, you build the different parts of your application, and you want to pull this code out into either a separate class or some tool like Dagger 2. And Dagger 2 basically creates a more complicated, automated version of exactly what you see here. I've even used the similar naming conventions. So that's a really important point here. If you're doing it for a learning project, by all means do that. Don't use tools like that in small applications because it's really not to your benefit. Again, maybe you want to keep your skills sharp or you have a specific reason why you're doing that. That's okay. That's good. But understand that sometimes it's a giant waste of time. And one more benefit here. By using fewer third-party libraries, we can drastically reduce the memory size of our applications. And sometimes that is critically important. If you have a very big application, you probably need to be worrying about the APK size or jar size. In Android, we use APKs, but in other Java land, we use jars often, or WAR files even. So actually, maybe I think it's called a WAR file in Java EE, but it's been a few years. So this is, kind of the final point here. So I'm almost done. We got one more point and we'll get through this pretty quickly. Then we'll get to Q&A. So how do we mitigate? This is kind of an English word for my ESL friends. It means like reduce. How do we, actually let's say that. How do we reduce the problems that can arise? Is that a Z? I can't remember. From good old English language. How do we reduce the problems that can arise from using frameworks? Well, if you've ever looked at Uncle Bob's work, he taught me about this originally. Keep frameworks in particular at arm's length. So don't let them take over your entire architecture unless you're sure that that's what you want to do. And so what I mean by that in code is that because I have, in this old application, decided to use RxJava as my primary framework for communicating data across the application, if I decide to switch to a different tool, or hypothetically I find out that RxJava doesn't work for me, then I need to do a gigantic refactor because I'm literally refactoring the framework of my application. So that's a really important point, and this is a reason why you have to be careful using those kinds of things. Here's a general prescription. Keep frameworks / libraries at the extremes of your architecture and not in the middle. So, we can use, use UI frameworks, which would be the front end. Use databases / network adapters. I don't care. Use Room, use Realm, use Retrofit, or don't. But keep these things on the extremes. So we have like the front end, and then we have like the middle stuff, which it depends on how you define that. And then we have the back end. And these middle classes, and we could consider like a presenter or a view model. Like nowadays when I write these things, you won't see a single third-party library in my presenter. That's basically what this is. You won't see third-party libraries in my view models. That's right. I basically no longer use Android view model. I'm not saying it's a bad library. I just don't really use it. You'll never see me communicating across an important architectural boundary of my application using LiveData or paging. You'll never see that because I'm just not even interested in doing that anymore. I've learned how to go without that. So I think that's basically all I wanted to say. And the final point, I mentioned this earlier, but by choosing not to rely too, I really hope I wasn't in webcam mode, good. By choosing not to rely too much on frameworks, you will learn a lot. Now, for the junior developers listening to this, if you have your frameworks and you like them and they solve problems that you're not really comfortable solving on your own at this stage in your career, that's okay. I'm not trying to replace one dogmatic opinion with another dogmatic opinion. I'm just trying to give you my perspective on this topic and why, several senior Android or senior developers throughout my career when I was a junior developer would say this. They would say, don't let these things just take over your entire development process. And by going through that example of just completely failing a coding challenge, because I couldn't do some very basic things in Android using only the Android SDK and the Java standard library, that really taught me exactly why keep your frameworks, keep your libraries at arm's length. And that is a saying by Uncle Bob. I don't want to make it sound like I made that up. Hopefully, I'm using quotes. I might be paraphrasing, but I think that's what he said. Okay, so that is my lesson for today. I hope at least some of you enjoyed that. And now I will take a moment to catch my breath and we can get into the regular Q&A. All right. So I haven't looked at the chat for quite a while, so let me just catch up here. Ted, apologies if I mispronounce your name. Ted just says some of your Android tutorials were very useful. Glad to hear that. Yeah, 2 hours. So Quabena in relation to my coding challenge that I failed. Yeah, they gave me 2 hours, which I think that's a little ridiculous for a coding challenge. But it just depends on what the employer's goals are. But definitely didn't really suit me that well. Radol says, I am shit scared of hearing you right now because I am only using third-party libraries. Listen, that's okay. Just understand there will be holes in your knowledge which you might need to patch later on in your career. Because, look, I used friggin' tons of frameworks for like the first 4 years of my Android career, pretty much from 2014 when I started with Android to 2018. I thought that frameworks were like literally how you built applications. Like the only way to do it. Respect Tech asks, have I checked out Proto Data Store yet? I have not. Could you let me know what that is? I'd be curious to know what data store is. Let's see what we got here. Inburst thinks it is 2020, so driving a tank to the store sounds pretty legitimate. Look, fair enough. That's a good point. But let's not take my analogies too seriously. Do we have any actual questions here? Did I miss any? Okay. Any questions that I can answer, anyways? This is an interesting question. So Noir asks, is competitive programming necessary to be a good developer? Just flat out no. No, not at all. I've never done a coding competition in my life. Would it be potentially useful? Like, would you be able to impress people because you won some coding competition and that might make you more likely to get hired? Yeah. I'm not saying it's pointless, but to answer your question specifically, is it necessary in the most literal sense of that word? Absolutely not. Here's just a personal anecdote. I was basically that person in school who typically did really well on assignments, and then, oops, I just accidentally changed. And then did pretty poorly on tests. In like intellectual kind of tests. I perform well under pressure, but as far as that kind of thing, I'm not particularly great at it. I don't like to compete against other people. I like to compete against myself. So anyways, I don't have too much else to say about that, but yeah. Let's see. Got a question by Rudy. Can I explain how I use private and protected methods? Everyone seems to use them differently. So I'll see what I can do with this. Let's just bring everyone up to speed on the different access modifiers. I'm assuming you're talking about probably Java, but obviously this will apply to many C-like programming languages. So let's just start. I'm just going to use Java as an example here to answer this question. So Java, so we have public, so can be seen anywhere in the project. We have protected, so this is can be seen in subclasses only. I might be slightly off on that definition, but that's the general idea. No modifier in Java is package private, and obviously private is visible in class only, within the class only. So first we have to look at what is the purpose of each of these things, in particular private and protected. So what's an example? Why do we make almost every field private or protected? And when I say we, I don't mean everyone, but I mean more advanced developers. So there's a particular point on why we do this. It is used as a mechanism for hiding, how can I explain this? Abstracting, there's a technical word that I don't remember that describes this, but it's used as a mechanism for abstracting data access from data modification. I feel like I didn't really explain that well, but let's look at an example. Okay, so let's look at a data model. Let's do day. So you'll see whenever I make data models, unless I'm subclassing something, I will almost always make my fields. So here we're talking about either reference variables, reference type variables, or we're talking about primitives in a class. I will always make them, almost always, private and final unless they need to change, but very, very rarely do they actually need to change. Excuse me. And then what we do is we make getters and setters. For final variables, we don't make setters, but for this, we make the data itself private. So we hide the data itself for security and protection. And then we have this thing here. We provide a way of accessing the data which is secure. An important point of Kotlin is that it actually basically is designed to do this out of the box with properties. So I'm trying to think of a way to explain this that will make, that gives like a really concrete example here. We want to hide how we access the data and the data itself. And the reason why we do that is we don't want, say, ourselves or other developers who are working on the project to have problems. So this is something you can look up. We want to avoid problems with accidental modification of the data and avoiding shared mutable state, which leads to race conditions. So in this particular case, by making my data private and final here, I am actually proactively making my code safer for not just me, but for the people who might be working on my team building this application. Because if we don't add these kind of access restrictions, then you can have someone accidentally modifying the data at a bad time or something like that. So that's one particular example. You know what? Let me just give you a general rule to follow. Here is a general rule. Use the most restrictive access modifier you can, which still works to solve whatever problem you are solving. So our goal is to overall try to use private, and if you can't use private, use protected, and if you can't use protected, don't use a modifier in Java. That means package private. And then if something needs to be globally visible, then you would use public. Now, probably you can look through my code bases, particularly the old ones, and you'll see examples where I didn't really follow that rule. But it's the principle that I try to follow. I'm not sure if I really answered your question, how I use private and protected methods. Everyone does do it. I see more consistency in senior developers. For senior developers, you will almost always see private final fields. But, and that hopefully I gave you some idea of why that is. It's actually sort of like a code security situation, making your programs more resistant to accidental problems or even hacking, essentially. So I think that's all I can really say about that, and hopefully that gave you some idea. I guess, so Rudy is C++ or Python. I think the same rule applies no matter pretty much what language you're using. We're getting into some abstract computer science. Just trying to make sure I spell your name right. I probably should have just copied and pasted it. Abdullahi, yes. Inheritance versus composition using interfaces instead of abstract classes. So down in the description, I'm going to answer your question, don't worry. Down in the description box below, you will see my course, Working Class Java, Fundamentals of Programming with Java and Software Architecture. In that course, I explain very, very clearly exactly what interfaces are for, exactly what abstract class is for, exactly what inheritance is for, and I don't use a lot of big words. I don't use big fancy words like polymorphism and composition and all these sorts of things. I teach it in code. So I'm going to explain to you a summarized version of that, and if you want like a really in-depth explanation with code examples, go check that course out because I put a lot of effort into that. So let's talk about a tale of three tools. So we have inheritance. I call this classical inheritance. This is kind of my own way of explaining this. So when we subclass from another class, we have interfaces. So when we implement an interface, and then we have an abstract class. We have, this is probably what you refer to as composition. We have abstract class inheritance. So when we extend an abstract class. So people who tend to focus on theory, they will focus on what these words mean in big, complicated technical definitions. And let me just level with everyone here. I never really actually learned how to use interfaces or abstract classes by reading some overly technical description of them. That never helped me. All it did was confuse me more. I used them in my applications and saw examples of them in source code, and that is how I learned to use it. And if you're wondering if I know what I'm talking about here, let's do a quick code demo of some code I wrote yesterday. In this code, you will see interfaces, and you will see an abstract class, which has a nested interface. So I know how to use these tools really well. Now let's answer these questions here. A tale of three tools. So what does classical inheritance, so we're just inheriting from a subclass, do for you? It does two things. It allows you to reuse code among any subclass. So it's about code reuse, and it is a weak mechanism for abstraction. So something a lot of people don't know about just extending a class, even though it's been right in front of you, is that it's actually a form of abstraction as well. And what do I mean by that? Let me show you just right away. If I do list, whatever, let's do a list of string, I couldn't care less, equals, or list equals array list, I should say new array list. This is basically just pseudocode, but yeah. If I say this, array list is a subclass of list, and I think I might, is this a correct example? Because that's technically an interface. I picked the wrong example because I have to be subclassing from a class, but the point here is that it's a form of abstraction. We can, I need to use the code that I used in the project. Just give me a minute. Let's go to bracket cove. I have a long and storied history of beginning to teach using the wrong example, but it's okay. We'll get to it eventually. Okay, so let's see, WJC demo code. And hopefully I can find my example here. We'll go to 4 is where I talk about all of these different tools. We'll go to 2. Okay, so, and where's the example? I think this is it. Okay, so this will be a better example. So exercise and then cat stretch. Okay, so we have a parent class called exercise, and then we have a subclass, of a subclass actually, but these are all classes, called cat stretch. And in my code where I use these different subclasses, notice how I can put them all into one list of type exercise, and we can basically consider all of these different subclasses as being an abstract exercise. So this is the point I was trying to make here, that it's a weak mechanism for abstraction, and it is a strong mechanism for sharing code. Interfaces are a weak mechanism for sharing code, but a strong mechanism for abstraction. Now, to be perfectly honest, Java has added default methods and a whole bunch of other things to interfaces which effectively have the goal of sharing code instead of abstraction. So I understand if you're going to mention default methods, then technically it doesn't follow what I'm teaching you here. But this is just because Java has basically been confusing this issue repeatedly and solving very specific use cases by changing the interface, whatever technical stuff. Interfaces, so they're a weak mechanism of sharing code. What do I actually mean by that? What I mean literally, and I mean in a very specific way. Interfaces, again, with the exception of default methods, they only allow you to share method stubs. So a method stub, or an abstract method is another way we can call it. It's got a return type, it's got a method signature, but it doesn't have a method body. You're not allowed to include the body here, again, unless you use a default method. Okay, so that is why they are, as I say here, a weak mechanism for sharing code, but a strong mechanism for abstraction. Now the thing about this is you have to understand, which one do we pick? We pick the one that is appropriate to solve the problem at hand. So if you followed my definitions here, then we get to the abstract class. So what is an abstract class? An abstract class is a strong mechanism for sharing code and a strong mechanism for abstraction. So an abstract class essentially is a combination of the interface. It does what an interface does, and it does what I call classical inheritance does. When you need to, let's go into a particular example here again. So in this case here, I'm writing some implementation. So here we're actually including implementation, the method bodies. It's not just method signatures. We're still keeping a good degree of abstraction, but we're allowed to actually do this. So in the case where you would want to use an abstract class, when to use an abstract class over an interface is if you need both strong abstraction, and again, when I say strong abstraction, I'm saying method stubs. We don't need to get into the big fancy words. If you need a method stub, which you need to implement in different ways depending on which class implements it, then that's what you'll do. And you need to share code across all subclasses. Now, I explain this a lot better in the course. I'm just giving you basically a lesson off the very top of my head, but this is how I think about these different things. They're different tools, and they have different purposes, and the way that you figure out which one you need is you look at the problem at hand. Do I just need to share some code across some subclasses, or maybe do I think what they call aggregation, like this example here? Well, in this case, a subclass is perfectly fine. We don't need to define an interface or an abstract class. Do I have a situation, like for example, when I'm talking from the front end of an application to the back end of the application, where I want this to be very abstract? I have no idea what will be in the method body here, whether it'll be Firebase or Room. The thing that uses this interface does not know or care how this, whatever implements this interface, solves the problem. All it cares is that whatever thing implements this interface returns an array of domain models and has a method called getData. So hopefully that kind of makes sense. It's not an easy thing to really understand for junior developers, but keep working at it, and eventually you should be able to figure it out. Just give me some moment here. All right, very good question. So RespectTech asks, have I messed with, let me add your name in there. Have I messed around with custom views? So I always get confused. I'm going to assume that, so this is actually something I'm myself confused about. Custom view versus compound view. And I don't actually have a strict definition. Let me show you something I did recently. So I had a problem in my UI, which feature, I think the hour fragment, hour view. So I had these, let me just let this thing load for a minute. Oh, and it's not going to load. Piece of shit. This is just a bug, so I can't use that example. That's annoying. This is just a rendering bug, but this is, it's friggin', it's 2020 and Android Studio's design editor still frequently fails to impress. Okay. I had these things that I call hour toggle views. Let me see if I can find one here. So see, it renders properly here, but when I include it in this thing, it doesn't render at all. So it's basically one of these things. Why is this so messed up? And I have 4 of these things stacked in this particular feature, as you can see here. So the way that I implemented this is first I created this layout, which just is, it's a compound view. It's a collection of different subviews. And then I created a subclass. I can't remember what I called it. What did I call it? Our toggle view. So I created a subclass of either a view or a view group in this case, and it contains a collection of the various views that exist within this custom view, I'll call it, or compound view. And basically what we do is, instead of just having like basic views that we're referring to in the adapter, I don't remember if I actually implemented this. Let's go to fragment hour view, I think. Yeah. Oops, no, I want the class fragment. Our view, here we go. So in the actual class which uses my custom views or compound views or whatever the appropriate word is, as you can probably tell, I'm much better with concepts than words. So we create 4 of these things, and I basically hide a bunch of logic, which has to do with drawing and inflating and building these views the way I want them and manipulating them, setting the time label, there's a spinner here, there's a switch here. So we do all of this management of these things and creating the adapter and all that kind of thing. We do it in a custom view class, essentially. And this is something I also learned to do recently, and I do quite enjoy doing that. It worked out really well. It makes my fragment a lot simpler, and I can manipulate it kind of the way I want it. Like when I give the data that I want to display to this fragment, I just create one of these toggle view things, and I give it the data that it needs. And I even have this function here, finding the quarter view. Yeah, good stuff. So, yeah, I think I basically, hopefully, I'm not sure if I gave you the answer you were looking for, but I gave you an answer nonetheless. Okay, so, a question from Mridal. So, do I use data structure algorithms, for example, bubble sort or a binary search tree in an application, or is it just used to crack the coding interview? So, I've got a 2-part answer. I have not really used any of these specific and well-known algorithms in application code. I have studied asymptotic runtime. If you're a beginner, don't worry. This is a software engineering question, and just don't worry if you're a beginner. So I have studied asymptotic runtime complexity, and I've used this topic to write better code very frequently. Now, here's the thing. The thing we need to understand about all of these algorithms is that when n, which refers to the number of inputs, I'm assuming, Mridal, that you have a basic understanding of software engineering. If you don't, let me know. When n is small, number of inputs is what that means, or the size of the data set. So when n is small, we do not really see much of a difference between algorithms. Some might perform slightly better with very small data sets than others, but we don't actually see a significant performance improvement across a wide variety of data structures. To generalize, I'm giving a general opinion here. So this becomes more important as we build applications with a very large data set. So for example, I'm thinking a social media application. So I have not actually myself built an I've built a demo social media application, but I haven't worked on or built an actual social media application which has hundreds of thousands, millions, billions of users. And so if you're going to be working on an application which does have very large numbers of inputs, whether that's users or just some other kind of data, that's when all of a sudden these things like using bubble sort or using merge sort or whatever become important. And that's when it's like a really regular and important part of your day job. So now the thing about that is, you know, if you're applying to a company like Google or Facebook or Amazon, yeah, you're going to want to need to know that because they're going to be asking you all kinds of questions about data structures and algorithms. If you're an independent developer and you're just making a small application and it doesn't deal with big numbers of inputs, then you probably won't really be using much of this information. I still encourage any level of developer to learn the very basics of asymptotic runtime complexity. I should add runtime and space complexity in big O notation. These are some things you can look up. I tried to explain these at the beginning of the second live stream, number 2. So if you want my kind of long explanation of this topic and data structures and algorithms, you can go back and watch that episode. But yeah, hopefully that answers your question. Okay, we got a question from Jundi. So I heard about the service locator. I heard that the service locator should be used instead of a DI framework to reduce dependency to libraries on simple apps. How and why? I'm not sure who told you that, because there's a grain of truth in the statement, but let me kind of burst that bubble. Most DI frameworks under the hood actually are service locators. I believe this is even now true of Dagger 2. I think initially it wasn't, and then eventually I think they did actually end up backing it with a service locator. So let me kind of unpack this here. So there's a problem. I'm just going to kind of pick this apart. I'm not criticizing you, Jundi. I'm just going to criticize this idea a little bit. So we can build our own service locator or a service locator, almost lactator. That would have been hilarious. Service locator. We can build our own service locator or use one from a framework. So the important thing to understand here is that like dependency injection, it can come by writing your own thing or it can come from a framework. I do absolutely agree. In a simple app, do not use a DI or even, to be honest, a service locator framework unless your goal is to learn that framework. Unless you're building an application, a simple app, expressly for the purpose of learning some particular framework, don't do it. Let me explain why. Let me show you how complicated. Do I even have, I think I have a service locator here. Let's see. Maybe not. Let me show you how, I do have the service locator. So here we have a small, maybe, depending on what your definitions are, medium-sized Android application. Let me pull up Build Gradle, the app module. And you'll notice I don't have Dagger. I don't have Coin. I don't have, what was the other one, Codeine. I don't have Hilt because there's no point. Not no point. I shouldn't, that's an absolute statement, and I don't like making absolute statements like that. But I gain no benefit for my goals by adding any of those libraries. What I do instead is that for each feature of my application, I write this injector class. And this injector class is effectively what a tool like Dagger would do for you. It hides the logic required to build the feature of the application you're working on. So this is effectively what, whenever we call like Dagger application.inject or whatever, that's what we're doing here. And then we pass in our view or our context. That's exactly what I'm doing here. We pass in the view or whatever, and then we build the components and we wire everything together here in its own isolated part of the application. I call this build logic, and the purpose of a service locator and dependency injection, the overarching goal here is we're pulling the build logic out of the things that use that which gets built. I hope that makes sense. There's a principle here. In either case, let me see if I can remember it off the top of my head. Martin Fowler says the principle of separating configuration from use. So configuration meaning building things. By the way, if anyone wants to learn from a developer who is way better than me, look up Martin Fowler, buy his books, read his blog. Very good. Yeah, so the principle is separating configuration from use. So let me, I'm kind of going all over the place here, which is surprising because I haven't even had a second coffee. But what I suggest for simple applications, write like a little injector class. So for each feature of my application, I'll write some injector class. Here I do use a service locator. Let's actually look at that. So a service locator is basically you hold on to whatever services your application needs to have, and understand that if we're building a giant application, then service locators can be a problem. If I have like this many services and then I have one class referencing all of this stuff, if I'm not using at least lazy loading, then I'm potentially setting myself up for some memory problems. But in simple applications, all we do is we just have, we have these references to these things and we hold them as interfaces because the classes that use these things only know them through interfaces. And when we create this thing, we pass in the context and then we, create whatever framework or scaffolding we need here. Here I'm using a Java executors framework for concurrency. We build the services, and then we have our public getters. Earlier we were talking about having private fields and then public getters. And then in the class that needs to use these things, we have DayViewLogic. We can either give this class a service locator, and in really complicated applications, very often I will give it a service locator, or we can just use that service locator in our build logic so that we can get the things when we need them. So I hope I answered that question. The general idea here, so let's just break this apart one more time. Using service locator instead of a DI framework, that part doesn't make a lot of sense. I do like the idea of reducing dependencies to libraries in simple applications. I do agree with that, and hopefully that answers your question. Okay, got another question from Rudy. Quick question about MVC. Is it considered I can't talk. Is it considered a design pattern? I've read many design pattern books, and I don't see the MVC described in any of the three design pattern families. Okay, so I have to give a caveat here, and this is something really important for any junior and intermediate developer watching this right now. There is surprisingly little consensus, which is a big word for agreement, about what these words mean and even how to build them. So before I answer this question, you've got to understand, some developers would say absolutely MVC is a design pattern. Some developers would say probably that design patterns are these specific things explained by the Gang of Four, which is a group of 4 people who pretty much invented the term design patterns and kind of defined it. Here's what I would say. So if I ignore everyone else's opinion and I go with my own understanding of what a pattern in code means and what that refers to in architecture, in my opinion, MVC is absolutely a design pattern, which is meant for designing a GUI system, a graphical user interface system. Absolutely, it's a design pattern. We could talk about a facade pattern, which is a much smaller pattern. Sometimes we refer to it as the repository pattern. But yeah, here's what I think about patterns. If someone shows me a well-documented UML diagram, I hope you all know what UML is. Let me pull up an example so anyone who doesn't can follow. What's a good example here? I don't want to, let's do Wikipedia because I don't want to be propping up any particular website. And this will help to answer this question. Okay. So UML, let me show you what that looks like. So this is an example of one style of UML. And this describes the architecture of an application, and the specific lines and symbols and things mean specific things. Now, here's how this ties into MVC versus a design pattern like the facade pattern, like the observer pattern. There's kind of different subsets. Some people might say there's like structural design patterns, and I forget the other words they used to describe these things. But here's why I would consider these things all under the umbrella of design patterns. If you show me a UML diagram of MVC or something like a facade pattern, and you give me even just a basic idea of what the UML diagram is doing, but you hide all of the names, I can very often pick up and identify the pattern just by looking not at the names, but the structure, the arrows and the lines and what those things mean. So for that reason, I can apply that same thing to my knowledge of MVC, to a facade pattern. I can look at it without the nouns, or having very, very little information about the nouns, and still identify it as a pattern in the code or the architecture of a program. So for that reason, I would personally consider MVC or any GUI pattern architecture to be a pattern. I think they might even say like it's an architectural pattern. Now, when I say these sorts of broad statements, not everyone agrees with me, and I might not be 100% correct. My general stance is that other people like to get really, really picky about definitions. I care about writing code. What does MVC mean to me in terms of writing code? What does the facade pattern solve for me in my applications? Those sorts of things. I don't get all bent out of shape about whether I have the right jargon explanation to any particular thing. So that's my thoughts on that. Glad that answered your question. Okay, so I'm not going to talk for too much longer because I'm getting kind of tired here, but let's keep going. I'll try to give this, I'll try to give some thoughts here on this question. Every day asks, I want to make an app like Uber, controlling all buses' location in map during work time. How to handle and which tools to use. Background task, live server, WebSocket. So I can't really give you a strict answer for two reasons here. Number one, there's many different ways to do that, and kind of the whole point of this episode was to talk about you can implement these things yourself, like you could implement the socket API in your Java application. If we look at Java, you'll notice that Java does have part of the standard library, the .NET package of the standard library does have these socket classes that you can use. Or you could use some kind of framework, and I won't go over that. We talked about that earlier in the show. Yeah, probably you would need map API. You might need to brush up on graph data structures, which are used heavily in networking and map applications, heavily. And this would be, if you want to make an Uber clone, like a proper one that actually handles large data sets, you're going to need to learn some data structures, or you would benefit from doing that. As far as like a particular set of tools, I haven't built an Uber clone, so I'm just not really the best person to ask that question to. And like I said before, there's so many different ways to do it. So I apologize that I can't give you a better answer than that, but that's what it is. I could make stuff up, but that wouldn't be very useful for either of us. But yeah, probably you would want to use the map API, and I think this would be a good thing to look into. I've thought about similar applications, and this is really where I would focus a lot of my learning. Let's see. So this question will be from Reza, and I'll probably only do about 2 more questions. So I see, Reza, you just joined. You're going to want to go back and watch the earlier part of this episode, because I actually explained all about using things like RxJava and Flow, and this actually captures the whole point of this episode, which is that frameworks change all the time. Last month it was RxJava, this month it's Flow kind of thing. Okay, so let me answer the question. I've started to learn RxJava about 2 months ago, and I used it in my project this month. Suddenly I realized, damn, JetBrains guys built something named Flow. Shit. Do you suggest using it? So what you'll find is that every 6 to 24 months approximately, a new framework which does basically the same thing as the old framework and sometimes not even better. I'm not saying that about Rx and Flow specifically. I would prefer Flow over Rx, to be honest. I like Rx, but it's just ugly to look at, in my opinion, and it's a pain in the ass to learn. Not saying Flow is easy to learn. What you'll see is that every 6 to 24 months, a new framework comes out, and sometimes it's not even better. So to answer your question here, do I suggest using any particular framework over any other particular framework? You have three choices. Rather than telling you which choice to make, which would be irresponsible of me, I'll point out the 3 choices. Stick with RxJava. And what'll happen there is that since Rx is a mature code base, it will probably change less over time, but it may soon become unsupported. I'm not saying the creator of it, I believe this was created by Artem Zin, but I could be, maybe I'm just pulling that out of my ass. It might eventually become unsupported if the number of users really declines. You can learn the new framework, and usually companies like to see you learning new frameworks. I'm not saying that's a bad idea. I'm not saying any of these are bad ideas. Or the other thing you can do is learn to solve the problem which these tools handle by writing your own solution. So these are the 3 choices in front of you. If you're a real junior developer, I don't know what your skill level is, and you're mainly concerned with getting a job or an internship, I would probably either stick with RxJava. Being good with this tool will impress people, hopefully. Or learning Kotlin Flow, knowing the most recent popular library that's the best thing ever, that will in probably 6 to 24 months just become obsolete. That will also might be useful for your job prospects. And to be honest, being able to solve these problems in your own code, that will make you a very good developer, and you will have code which is very resistant to change. On this particular topic, I'm not really going to encourage any particular thing, but if you're in Kotlin, if you're writing Kotlin, I would probably go with Flow and coroutines. And the reason why is that we're using basically a language library as opposed to using... now, I'm not sure if Flow is actually part of the Kotlin standard library. I haven't actually looked that up. I've been coding in Java for like a year, so I'm actually a little bit behind on Kotlin. Let me just look that up right now. Or if anyone in the chat knows, this is one thing I hate about the Kotlin website. I just want to see the API documentation, and it's really hard to find for some stupid reason. Where is the API docs? Okay, Kotlin. All right, you know what? Screw it. I'm not even going to bother. But yeah, hopefully that kind of answers your question. You're very welcome, Jundi, for the answer. All right, so Jundi again. Jundi asks, should I learn to create my own service locator to reduce using other libraries, or just use Dagger because it's basically the same? Again, so in small apps, using tools like Dagger or some third party, let's try and write English reasonably well, using tools like Dagger or some third party service locator is pointless and a waste of memory unless your goal is to learn that particular tool. In medium to more so large scale applications, then we can hit a point where writing the code yourself is less efficient with respect to like program efficiency. We'll say like program efficiency and developer time, like how long it takes for you to write the code. Then you can hit a point where where writing the code yourself is less efficient than using a tool like Dagger or Hilt or whatever. This is really the trade-off, and I actually wrote an article about this, which I might share in the links here. I thought I wrote an article on this. Maybe I didn't. Maybe I was writing. Okay, never mind. I think I was writing an article and I haven't actually finished it, but yeah. So yeah, that's kind of my opinion on that. I think everyone should learn, like the service locator, it's a really, really, really simple thing. It's basically just a class that holds onto your services. So that part's really simple. If you're gonna bother using frameworks for build logic, I probably would do something like Dagger. All right. Oh, I'm very glad my answer was useful. Everyday learn. Okay, well, I'll just stick around for if there's any really short questions or comments people have. But I'm bloody tired, and oh yeah, no problem, Jendi. You don't need to apologize for anything. It's a good question. I apologize. I'm getting kind of tired, so any final questions or comments that I can answer really quickly? I'll stick around for a couple minutes, and then we will call it a day. What's up, Chaitan? Chaitan. What's up, Chaitan? Oh, yeah. Oh. So I hope that episode was useful for people. Got some more interesting kind of abstract programming questions about tools like abstract classes and interfaces and those kinds of things. And I did my best to answer them as best as I could. But obviously I don't have all the answers. Yeah. So it's worth mentioning at this point that if you like what I do and would like to see me do it better, or if you want to learn how to be capable of on-the-fly building clean GUI architectures which don't have any third-party libraries, using interfaces and abstract classes and generics and all these advanced tools which we see in Kotlin and Java, then down in the description box below, you will find links to my courses. And the Skillshare links, if you haven't signed up with Skillshare already, you get a 2-month free trial, which gives you access to all of my courses for 2 months for free. It's a subscription-based platform. There's the Udemy link. I don't really like Udemy, but hey, it's there. And the Udemy course, because Skillshare doesn't have subtitles and captions, the Udemy course has been translated into Arabic and Burmese subtitles. So if you happen to be speaking Arabic or Burmese, then that might be quite useful for you. And yeah, so do consider supporting that. And again, shout out to Rowena Polak for the donation via PayPal. That was much appreciated. Yeah, I know, Chayton. So Myrtle, I've got like a Halloween lighting going on. I just don't have the best setup, so that's why it's caused why it looks like that. Chayton Myrtle mentions that I look like a Viking and I need to get an axe. Well, I actually do have several axes, and I do have Viking blood in my veins. So fair enough. As you can probably see, I get a lot of people telling me that I look like Bjorn from Vikings. And after like 2 years of getting stopped on the street and people literally saying like, you look just like the guy from Vikings, I finally thought, okay, you know what? Screw it. I'll just grow the beard out and I'll just roll with it. All right, thanks for watching, everybody. I wish you all a happy Sunday. I have to go spend 3 hours cutting firewood, so I'm going to go eat some food so that I don't pass out. And then it'll be back to coding. Peace out, everybody.